Take these up. So first column is sum of x1, second column sum of x1 squared, and the same thing for x2. Step number 2, in step 3, we are doing sum of square 1, and that is the formula we are using. So we got the result for sum of square 1, meaning sum of square from sample 1. And we did the same thing for sum of square 2. Sum of square 2, that is from sample number 2, which is N2. And after we are done with those, then we are calculating this standard deviation here. It is, if you look at page number, what is it? Page number 130. If you look at page number 130, it's in your handout. Everything is in your handout. We are calculating the standard error of the difference between means. That's what we are calculating, because the main idea was, if you look at the hypothesis, then we are focusing on the difference between means. We are basically saying that there is no difference between these two means, even though the samples are independent. So standard error of difference between means, that's what we are calculating. And that's what we did in this one. So we got that value. After we got that value, then we calculated the last thing in step number 3, which was the T obtained. And the formula for T obtained is also given on your page number 130. So this is the formula we are using. That's the formula we are using for your T obtained. What did I do? I put a square box in it and put an asterisk on the left hand side. So that is the formula we are using for T obtained. M1, again it is this x1 bar, so mean from the first sample. M2, the mean from the second sample, divided by the standard error of difference between means. So that's the formula we used in this one to calculate the T obtained. So we got the T obtained, we also got T critical, and what do we have? If you compare the T obtained with T critical, what do you see? They are not equal. So that means, that's why we are writing this statement that students who read newspapers scored significantly higher than students who watched ESPN. That means these two means from the two different samples, they are not equal. How can we say that the students who read newspapers, they scored higher? How can we decide on that statement? Look at the T obtained formula and then you can find out. The T obtained formula, look at the top part. 39.7. And the other one, who are watching ESPN News and Sports Center, their mean was 33.3. So the mean for those people who are watching the newspapers, that mean is higher than the ESPN, people who are watching the ESPN Sports Center. That's why we can make a statement that students who read newspapers, they scored higher significantly than people who watch ESPN. So we reject H sub 0. Our T obtained is plus 2.23. If you have a negative one, then you will mention it's negative 2.23. And you will write this way, like P is 0.05, because that's what we have been given at the beginning of our question. And looking at the effect size, then we have another set of calculation, and that's what we did in this one. And that formula is given on page number 134. Yeah. That's the formula on page number 134 for your Cohen's d. So once we calculate that Cohen's d, and then based on that, those values, we can mention whether it's a large effect or small effect or medium effect. Again, those Cohen's d, remember those values is the same values we're using. Only thing different is the formula is different here.